Stub areas is one of the most challenging topics in OSPF. In this video, I make it simple. I will go one step at a time, understanding the basics such as route types, then link state advertisements, and the different types of stub areas. Welcome to the network trip. When working with OSPF, we'll manage three different types of routes. The first one is intra-area routes. Those are routes that are generated inside the current area. For example, if we are inside Area 7, from the perspective of Area 7, the intra-area routes are the routes that have been originated inside that area. So those are intra-area routes. Then we have the second type. Those are inter-area routes. Inter-area routes are routes that are coming from a different area, but inside our OSPF domain. If the Area 7 is getting that information from those areas, those are going to be inter-area routes. Then we have the next one, and that is the external routes. External routes are routes that are coming from a different routing domain. They are not originated inside the OSPF domain. For example, in this topology, we have the Autonomous System 200 that is running OSPF, but we have two ASBRs. That is the router 8 and the router 9. Those are the Autonomous System border routers. You can see that those are connected to external routing domains. So we have one routing domain that can be running BGP. For example, we can have a second routing domain that can be running BGP, OSPF, or any other routing protocol. The simple thing that matters is that we have routes that are originated outside the OSPF domain, and those are going to be external routes. Once we are clear and we are able to identify intra-area routes, inter-area routes, and external routes, then we can jump into the next topic. How is OSPF going to exchange, to advertise the information about those three different types of routes? And that is by using what is called link state advertisements. Depending on the type of information that is inside those LSAs, we are going to have different types. For example, the first one is LSA Type 1. LSA Type 1 is a message that is going to contain information about the router, all the connected networks in one OSPF router. If I jump to the topology that we'll be using in the lab today, we can see that inside this yellow box, we have the OSPF domain. We have 5 areas, area 0, 6, 7, 8, and 9. Every router in that OSPF domain is gonna generate an LSA Type 1. For example, R5, that guy there, is gonna generate a message LSA Type 1. That message is gonna contain all the information about the connected networks in that device. All the networks that we are advertising via interface templates will be inside that LSA message. Every router inside the OSPF domain is gonna generate the LSA Type 1. The next type is the LSA Type 2, also known as Network LSA. So this is used only in broadcast networks. If we are using in an interface template the network type broadcast, we're gonna have the network LSA. Let's go to the topology to fully understand how the LSA Type 2 is gonna work. For example, in this topology, I'm using a broadcast network type between all those routers in the backbone. So we can see that all those devices in that area are connected to a network 10.0.0/24. If I check the interface template, the network type is broadcast. When we have a broadcast network type, one device is going to be elected as the DR or designated router. A second device is going to be selected as the backup designated router or BDR. Basically, once we have those devices, there will be a full adjacency between the remaining routers to the DR, and also we are going to have a full adjacency to the BDR. The point here is that those routers are going to send the LSA Type 1 out of all the full adjacencies. That information will be received by the designated router. The designated router is going to generate a new LSA that is called LSA Type 2 to exchange the information with all the routers in that broadcast network. In that way, we don't need to have full mesh adjacencies inside that broadcast network. The DR is going to receive the information from all the routers in the broadcast network, and then it's going to send the LSA Type 2 to all the remaining routers, and now the router will have the information. So basically those are the LSA Type 1 and 2. LSA Type 1 and 2 will be inside the OSPF areas only. So you can see here in this diagram, a Type 1 or 2 is not going to travel from one area to the other. Then we have the LSA Type 3. This is called a summary LSA that is created by the ABR or the area border router. So we have one router that is connected to the backbone, then is connected to area 1. That ABR is going to generate the LSA Type 3 to send the information from area 1 to the backbone, and also is going to receive the information from the backbone and is going to inject that information into the area 1. If we check our topology, we have those areas. So in this case, these guys here will be sending the LSA Type 1. This is a point-to-point network, so in that case we don't use LSA 2s. That router is the ABR. So now that device is gonna send an LSA Type 3 containing the information about the area 6. And now all the remaining devices are gonna send LSA Type 3s inside the rest of the areas, and now all the areas will have information about the area 6. So by using LSA Type 1, 2, and 3, we are able to exchange information about intra-area routes and inter-area routes. But we are still missing the external routes. So those external routes will be advertised by using messages that are called LSA Type 5. For example, in this case, we have an external routing domain connected to that OSPF network. So that router is called the Autonomous System Border Router. That ASBR is going to generate LSA Type 5 messages to advertise the external networks. So those LSAs will go over area 1, eventually will hit the ABR. Now the ABR is gonna take those LSA 5 messages and it's gonna inject those into the backbone, and then the backbone will float it across all the areas in the domain. But additionally, the ABR is gonna generate another LSA that is the LSA Type 4 that basically contains information about the ASBR. Now everyone will be able to locate that ASBR that is generating the LSA Type 5s. So those are the messages that we typically use. So the LSA Type 1 and 2 are for intra routes. LSA Type 3 are for inter routes. And then 4 and 5 are used for external routes. Once we understand the different type of messages that these devices are using to exchange those different types of routes, we can jump to stop areas. There are 4 different types of stop areas. A stop area is basically an area that is gonna filter some types of LSAs. We'll go one by one. Let's start with a stop area. So the stop area is gonna accept LSA Type 3s, but it's gonna block LSA 5s, 7, and also is not going to allow an ASBR. So basically this means that if we are working with a stub area, this is going to manage intra-area routes, and it's also going to manage inter-area routes. And optionally, we can have a default route. So it's gonna drop all the external routes. Let's jump to our topology. At this point, the OSPF domain is basically using default areas, following the same process that I explained in one of the previous videos here in the channel. If you are not familiar with multi-area OSPF topologies in RouterOS 7, please check the video above, and then you can return to this point to continue configuring the rest of devices. I will assume that at this point you know how to configure multi-area OSPF topologies. We have the backbone area, and it's that area on the left. We have 5 routers that have interfaces connected to the backbone. Then R2 is an ABR, because R2 has an interface connected to the backbone and has another interface connected to area 6. R6 is an internal router. All the interfaces in R6 are connected only to the area 6. That area is advertising 10 routes, and those routes are 10.6.x.0/24. So those are intra-area routes. Same thing is happening with area 7. So we have R3, that is an ABR, one interface connected to the backbone, another interface connected to area 7. Area 7 is also advertising 10 routes, 10.7.x.0/24. Those are intra-area routes for area 7. Then we have the next one, area 8. Exactly the same thing. We have R4 as an ABR. We are announcing 10 routes, 10.8.x.0/24. Those are intra-area routes for area 8. Then we have area 9. R5 is the ABR, one interface connected to the backbone, one interface connected to area 9. That area is advertising 10 routes, 10.9.x.0/24. So you can see that if I go to any of those devices are gonna have a pretty big routing table. So in this case, we are announcing just 10 routes, but we can have hundreds of routes coming from different areas. Additionally, we have 3 ASBRs. R1 is connected to one external routing domain. So this can be a domain running BGP, another instance of OSPF can be running RIP, for example. The point here is that those routes are coming to R1, and then R1 is redistributing those routes into OSPF. So those are going to be external routes from the perspective of the OSPF domain. Same thing is happening with R8. So it's connected to that external routing domain that is announcing 8 routes. So those are going to be external routes as well. Then we have R9, another ASBR that is also getting some routes from that routing domain, 8 routes in total, and then it's redistributing those into OSPF. So we have 8 plus 8 plus 9 external routes coming from 3 different external routing domains. So if I go to any of those devices, I will see all those routes. I will see some intra routes, I will see some inter routes, and additionally, I'm gonna see some external routes. Let's check the link state database in R6, and we can see all the information that OSPF is sending to this device. This is R6. If I go to routing OSPF, we can see that I have a pretty simple configuration. So we have an instance, then we have the areas. So in this case, this device R6 is connected to the area 6. If I go to LSA, so we can see all those LSAs that are coming from different sources. So we can see the router LSAs, those are the LSAs type 1. Then we have inter-area LSAs, and then we have the external routes. If I go to IP and then routes, we can see the routing table that is showing a lot of information coming from different areas. So here we have the routes coming from area 7, from area 8, from area 9, and then below we have information about the external routes. We can end with a pretty large routing table. My first task is gonna be to convert that area into a stub area. So now instead of being a default area, this is gonna be a stub area. Area 6 is gonna be a stub area. That means that area 6 is gonna accept LSAs type 1, type 2, and 3, but it's gonna block all the external routes, LSA type 5 and 4. We are gonna see that all the routes that are coming from those external routing domains are gonna disappear from the routing table, and we'll get only the intra routes and the routes coming from a different area inside the OSPF domain. So how are we going to configure that? We need to configure the stub area on the ABR and additionally in every device inside the area 6. If we have more than one router in area 6, we are going to configure the area 6 as a stub in all those devices. So let's go now to R2, and we need to modify the type from default to stub. And if I go to routing OSPF and then areas, we are gonna find the area 6. So we can see that we have the type default. That field is the one that we need to modify to change the area type. So I'm going to pick stub. If I select stub, this is gonna change some flags in the hello message. We must use the same type in all the devices. If we are not setting the same type, then the adjacencies will go down. So I'm going to click OK. So going now to R6, and we can go to routing, OSPF, areas, and this device has only area 6, and I only need to change that to stub area. And now we can click OK. So we need to wait some seconds. The adjacency will come up. And so we can see that the adjacency has been established. We have the state full. And now if we go to the routing table, we are getting only inter-area routes. We are not getting external routes. But we can see that this routing table is missing the default route. And that is because we need to add the default cost. If we go to the official documentation from Mikrotik, we are gonna see this option, default cost, and that is under the area. And we can clearly see that we must set that value. This property is not available on the Winbox. If I go to the ABR and then to the areas section, and I open the area 6, I don't see any options for setting that value. So I must use the terminal. If I go to the terminal, and then here I can simply go to routing OSPF areas. We can print those areas, and we see that the area 6 is using the entry number 1. So we can simply say set default cost 10, for example, and then the entry. That is the entry 1. Now we print that we have set the default cost. If we go back to R6, then we'll see, and we check the routing table, now we can see the default route. The stub area has been configured successfully. We have inter-area routes, and also we have a default route. Still, we can reach the external networks, but we don't have those entries on the routing table. Then we have the next one, and that is the totally stop. So in this case, we are going beyond rejecting the external routes. This is also going to block the summary LSAs, the LSA Type 3. So that means that we are no longer going to have the inter-area routes. This means that we are not going to have information about the routes that are originated in a different area. Instead of having all those routes, we are just going to have a default route. So a totally stop area is gonna use a default route. So let's see how that looks in our topology. So now let's convert area 7 to totally stop. So how are we going to configure that? Again, we need to do that on the ABR and all the internal routers inside area 7. On the ABR, we are going to add an additional condition, and that is no summary LSAs. So let's go to R3, that is the ABR in this case, and the next one is going to be R7. So if I go to R3, we have the area 7. We need to change the type to stub. But we see this option, no summaries. So if I click that, this is going to be a totally stop area. All the inter-area routes are not going to be advertised inside the area 7. So if I click OK now, and then I jumped to the router 7, this guy here, we can go to areas, and here we are going to pick type stop. In this router, it's not required to use the no summaries. That is required only on the ABR. You can select that option, but it's not going to make any change. So in my case, I'm going to keep that disabled, and now we'll click OK. So now we have configured this totally stop area. But if we go to the routing table, we're gonna get all the inter-area routes. And that is not the behavior that we are expecting. And this is because we need to set the default cost. So again, we need to go to the ABR, in this case, that is gonna be R3, and we need to add the default cost. We must do that on the terminal. Same process that we followed with the previous area. So let's go to R3 and let's add the default cost, and then we'll see how all those inter areas will be gone. So this is R7, so I will keep R7 here on the right, and let's keep R3 on the left. I will go to the terminal, then routing OSPF areas, and now I will print the areas. So we have the area 7, stop, no summaries, but we can see that that is not performing any action. It's just removing the external route, but we still are getting the inter-area routes, and that is not the behavior that we are expecting. So we need to set the default cost. If I go and I say set default cost equals 10, and I will apply that to the entry number 1. Now we are going to get the result that we are expecting. The adjacency will be established again, so we can see that this is going through that process. We can see that the state is now full, and if we go to the routing table, we can see that we are getting a default route. We are not getting external routes, we are not getting inter-area routes. And that is exactly the behavior that we are expecting with totally stop, because we are blocking LSA 3s, LSA 5s. But still R7 is advertising the routes. If we go back to R6, and we can see that here we have all the networks that are being advertised by the area 7. The next one is NSSA. That stands for not so stubby area. So the main difference here is that we are accepting inter-area routes. We are not accepting LSA Type 5, but we can have an ASBR connected directly to that area. To allow those external routes inside that area, the ASBR is going to generate LSA Type 7 messages. So those LSA Type 7 are originated only on NSSA areas that have an ASBR. Let's check the topology and convert one of those areas to NSSA. So let's go with area 8. So we are going to convert area 8 into not so stubby area. So now area 8 is connected to that routing domain. So we have an ASBR. So the idea here is that we are gonna accept all the routes that are coming from that routing domain, and those will be advertised by using an LSA Type 7. But all the rest of external networks will try to get in that area by using an LSA Type 5. So those are gonna be blocked. So the only external networks that this not so stubby area is gonna accept are the external networks that are coming from that domain that is directly connected to it. So let's see how are we gonna configure that. We need to set the area type to NSSA on the ABR and all the routers inside the area 8. So let's do that now. So let's jump to R4 and then R8 and change the area type to NSSA. So let's go now to R4, then routing OSPF areas, and we'll go to area 8. So now this is gonna be NSSA. Let's click OK. And now let's go to R8 and we'll do the same. Routing OSPF areas, and we'll pick area 8, and this is gonna be NSSA. Now we can click OK, and we have the not so stubby area available. So that means that we are going to accept all the external route, but only from the routing domain that is directly connected to this area. If I go to that device and I check the LSAs, we can see those external networks coming from the routing domain that is directly connected as NSSA type. So the networks 120.10. So we can see that those are coming from the routing domain that is directly connected to R8. Still, if we check the routing table, we are not getting the default route. We are getting all the inter-area routes, and we are not getting the external route from the rest of the routing domains, but we don't have a default route. And that is because, again, we need to configure the default cost on the terminal. So let's jump to the ABR. So here we have R4, and then we'll go to routing OSPF area. Then we'll print. We can see that the area 8 is the entry number 1. So we need to set the default cost on the entry 1. And if we go back to R8, now in some seconds, we'll see the default route. So we are getting the default route by using the default cost in that entry. By using NSSA, we are accepting external routes from that routing domain that is directly connected. Additionally, we are accepting inter-area routes. That's why we can see all those routes coming from a different area. But we are not accepting external routes from routing domains that are not connected directly to this routing domain. And that's why we are not getting all the routes from the networks 50.10 and also 200.10. The behavior at this point is that the ASBR is sending the LSAs type 7. When those messages are hitting the ABR is gonna translate that, and now they will be LSA type 5s. If I go, for example, to R2 and we check the type for those external routes, now they will appear just as a regular external route and no NSSA. So let's go to R2 and let's check routing OSPF LSA, and if we go to the external LSAs, we're gonna see all of those there, and the type that they are using is external. They are no longer NSSA because the ABR has translated those LSAs to type 5. And finally, we can go with totally NSSA. So in this case, we are not going to accept inter-area routes, external routes using LSA type 5s, but we are going to accept external routes that are coming from a routing domain that is directly connected. So totally NSSA. So let's jump to the topology and make the changes to validate how that is going to work. So now we're going to convert area 9 into a totally NSSA. So I'm going to do that. So again, we need to configure the ABR R5, and also we are going to change the area type in every router inside area 9. So let's go to R5 now. It's this guy here. We are gonna modify area 9. So in this case, the type is gonna be NSSA. Then we need to select the no summaries. This is basically telling this is gonna be a totally NSSA. We are not going to inject the LSA type 3s or inter routes. Additionally, we have this option NSSA translator. If we go back to the presentation, if we are using an NSSA and we are injecting external routes and we are redistributing that, those type 7 LSAs will be flooded inside the area. But that ABR can translate those LSA type 7 into type 5, and then those routes can be advertised in the rest of the routing domain. If we have several ABRs connected to the area 9, then we can select candidate, and basically OSPF is gonna pick one of those to perform the task. In this case, I'm going to say yes. It's important to mention that the no summaries is mandatory only in this device if we need to have a totally NSSA area. We don't need to use these no summaries in the rest of the routers, only the NSSA type. So the next router to configure is gonna be R9 because we need to match the area type. So let's jump to R9. It's this device here. We'll go to routing OSPF areas and we have area 9. So here we only need to change the type to NSSA. And in some seconds, the adjacency will come up. So we can see that we have the full state, but if we go to the routing table, we have the full state, but still if we go to the routing table, we are not getting the default route and we can still see all the inter-area routes. So we must add the default cost on the ABR. So in this case, that is gonna be R5. So here we are on R5, we need to go to the terminal, routing OSPF area, then we'll print, here we have the area 9, this is NSSA, no summaries, and now we are going to set the default cost to 10 on the entry 1. Now we can go back to R9, and in some seconds, all the information will be updated. So we'll see the default route now, and all the inter-area routes are gone. So we can see here all the BGP routes, and if we go to routing OSPF LSA, we can see that we are just getting the external routes. Those are LSA type 7 because we see the type NSSA. We have the inter-area prefix. This is the default route that has been injected by the ABR, and also we have the LSAs ones. So this is how a totally NSSA area is gonna work. We are allowing some external route, but we are blocking the ones that are coming from routing domain that are not directly connected to this area. We have successfully configured 4 different areas using Stub, totally Stub, NSSA, and totally NSSA. I hope this video can be helpful for you, and I see you in the next one.